let's discuss the concept of magnetic coupling and dot convention in transformers. So we all know that the transformer working principle is what? Mutual induction principle, right? Mutual induction principle. Which is nothing but the principle of transformer. So we all know that the mutual induction is depends upon magnetic coupling. So that is positive magnetic coupling and negative magnetic coupling. So the polarity of mutual induction depends upon type of magnetic coupling. Polarity of mutual induction depends upon type of magnetic coupling. So in order to discuss the magnetic coupling which is responsible for the mutual induction principle, so we have to discuss the types of magnetic couple. Those are nothing but positive magnetic coupling and those are nothing but what? Positive coupling, and second one negative coupling. We all know that positive coupling means what? Plus M, it is represented with negative M, that's it. Or you can say M is positive, here M is negative, that's it. So first we would like to discuss positive coupling, later we will discuss negative coupling. So sense of winding is the main criteria to discuss about magnetic coupling. Then what is sense of winding? That is nothing but direction of orientation of winding. So we have same sense of winding and different sense of winding. So with respect to sense of winding, we have to discuss the type of magnetic coupling. Okay, the sense of winding is nothing but what? Direction of orientation of winding. That is, we have same sense of winding and we have different sense of winding. Now we have to discuss same sense of winding. So let us consider the core. So in this core we have to provide two coils. This is coil A, like that. This is coil B. So what is the meaning by same sense of winding? So let us take, this is beginning end of the coil, this is termination end of the coil, like that. This is beginning end of the coil and this is termination end of the coil. So you can say that this is same sense of winding. This is beginning end, this is termination end. This is beginning end, this is termination end. Same sense means what? It is from bottom to top in clockwise manner. In coil B also, this is from bottom to top in clockwise manner, right? So this is beginning end, this is termination end of coil A, like that. This is beginning end and this is termination end of the coil B. So now we have to connect the termination end and beginning end of coil B, like that. Beginning end of coil A should be connected termination end of coil B through a supply voltage, this is Vs. Okay, so because of the supply voltage, what is happening? Obviously there is a current, right? So this is the current direction. The current is like this, this is the current direction. Clear? Then by using right hand thumb rule, what is the flux direction? What is the flux direction? With respect to coil A, this is direction of flux with respect to coil A, like that. This is the direction of flux with respect to coil B. So by looking at this diagram, so phi A and phi B, which are aiding with respect to each other, right? Two fluxes are aiding in nature, that is, two fluxes are in same direction. You can say that this is positive coupling because the flux is aiding. The flux is aiding in nature. That's why this coupling is called as positive coupling. Positive coupling. This is with respect to sense of winding. And how we can define the positive coupling with respect to dot convention? So simple. You have to choose either beginning end of any of the coil or termination end of any of the coil. So now I am going to choose beginning end of the coil. So beginning end of coil A and beginning end of coil B. So I am going to put a dot at beginning end of the coil, like that, the beginning end of the coil B. Now you have to choose one end, whether it is beginning end of two coils or termination end of two coils. Now I am going to choose beginning end of coil A and beginning end of coil B. At that position I am going to put a dot, here also a dot. Now to detect whether it is positive coupling or a negative coupling in nature, now I am going to see the current direction. So with respect to coil A, see the current direction, the current is entering at this dot, right? Like that you have to check the current direction at coil B. In this coil B also the current is entering at this dot. So from coil B and coil A we have to conclude that the current is entering from both the ends of the two coils. Obviously the current is entering from both the ends of the two coils, which means nothing but what? The current is entering at dot points of two coils, which is nothing but positive coupling. This is about dot convention. Next, same sense of winding but different current direction. You can write that point. Same sense of winding with same current direction. Okay, now same sense of winding with different current directions. Same sense of winding with different current direction. Then again you have to take a core. For this core we have to provide two coils, same sense of winding. Starting from this point, the winding placement is like this. Coil A is completed. Again, see the statement, same sense of winding. Therefore, again from this point, means the sense of winding is same. That is called same sense of winding, right? So this is beginning end, this is termination end of coil A. Like that, this is beginning end, this is termination end of coil B. Let us say what is B stands for? Beginning end. What T stands for? That is termination end. Clear? So now what is the statement? Same sense of winding with different current directions. So in order to get different current directions, I am going to connect the beginning end of coil A with beginning end of coil B with excitation. Like that, the termination end of coil A should be connected to termination end of coil B. So with this we are going to get different current directions. Now with respect to this excitation, this is the current direction in coil A, right? Now current direction is like this in coil B. Then what is the flux direction with respect to current direction in coil A and coil B? What is the flux direction? This is phi A. What about flux due to current in coil B? This is phi B. Two fluxes are opposing in nature. So obviously this is negative coupling, right? What is the point here? Two fluxes which are opposing in nature, which is nothing but negative coupling. This is with respect to sense of winding. So with respect to dot convention, we have to tell. Now I am going to choose again beginning end of the coil A and coil B. Here is the dot, like that. Here is the dot. Then you have to see the current direction with in coil A and coil B. So with respect to coil A, what is the current direction? The current is entering a dot in coil A and the current is leaving at this dot in coil B. So in coil A, the current is entering a dot, but in coil B, the current is leaving a dot. So obviously the coupling is what? Negative coupling. If the current is entering from both the dots, that is positive coupling. If the current is leaving from the both the dots, that is positive coupling. If the current is entering at one dot and leaving at another dot, is nothing but negative coupling. That's it, right? This is about same sense of winding with different current direction. Now we would like to discuss third case, a different sense of winding with same current direction. Different sense of winding with same current direction. Different sense of winding. So obviously first I would like to place the coil A winding. This is coil A, clear. Coming to coil B, that is different from the sense of coil A winding. So which is from different, that is from like this. This is different sense of winding, because the sense of winding between two coils is different. Clear, right? Now I would like to place what is beginning end, what is termination end of two coils. This is beginning end of coil A, this is termination end of coil A, like that. This is beginning end, right? This is termination end of coil B. Clear? This is called as different sense of winding. So now I would like to connect a voltage source between beginning end and termination end of coil B, right? Like that, these two should be connected. Now because of this excitation, there is a current in the coil A. The current direction is like this. Same current can be, see the current direction, right? So we have currents in coil A and coil B. So obviously by using right hand thumb rule, this is the flux direction in coil A, that is phi A. This is the flux direction in coil B, that is positive coupling. Why it is positive coupling? Fluxes are aiding in nature, right? That is called positive coupling. Now we have to detect whether it is positive coupling or negative coupling by using dot convention. So I am going to choose beginning end of coil A. I like that. Beginning end of coil B. You have to choose whether beginning end or termination end, same. Now see the current direction. At this beginning end of coil A, the current is entering, like that. At this the beginning end of coil B, the current is entering. So from both the ends the current is entering. from this coil A and coil B, from both the dots the current is entering, obviously that is positive coupling. Now we will discuss different sets of winding with different current direction. With different current direction. Same, first I would like to place coil A winding. Clear? Now different sense, right, from this position to so this is what beginning end of coil A, this is termination end, like that this is termination end, this is beginning end. Now I would like to connect both the beginning ends of coil A and coil B with a excitation, like that both the termination ends like this. This is coil A, this is coil B. Now what is the current direction? Because of this excitation, the current direction is like this in coil A. This is the current direction in coil B. That's it. So by using right hand thumb rule, what is the flux direction? This is phi A, this is phi B. Obviously this is negative coupling, means fluxes are opposing in nature, that is negative coupling. So by using dot convention, dot at beginning end, dot at beginning. Now see the current direction at both the coils, the current is entering at dot in coil A, like that the current is leaving a dot in coil B. Obviously one dot the current is entering and at another dot the current is leaving, obviously this is negative coupling. This is about the sense of winding is the responsible to get the positive coupling or negative coupling detection. This is about the magnetic coupling with respect to dot convention. Now I am going to explain the important rules to get dot convention. So what are the rules? Ensure dot marks at beginning ends or termination ends of both the coils, whether it is beginning end or at termination end only, but not both beginning and termination. That is, one dot at beginning end and another dot at termination end is not considered. Like that, beginning end and terminating end of a coil should be decided based on sense of coil but not with direction of current. So the whether it is beginning end or termination end, that is totally decided which is respect to sense of winding only but not the direction of current. Okay, access flux produced in the winding which is aiding or opposing. This is done by seeing the direction of currents at dot. If it is positive coupling, the flux is in same direction, and if current entering or leaving at both the dots with the dots at similar ends. Like that, coming to negative coupling, the flux which are in opposite direction, and if current entering at one dot and current leaving at another dot, then only we can say that is negative coupling. So in order to avoid any confusion, just go through these rules first, later we have to analyze for different cases. Thank you.